Gyan Niketan YouTube channel. I am Dr. Harendra Kumar Sinha, going to describe the differentiability of a function at some particular point. So let fx be a real function, and x is equal to a be a real point. What do we mean by the real function? The domain and codomain of the function should be a subset of the set of real number, and x is equal to a be a real point, meaning thereby a is the real number. Now we define the left-hand derivative by the limit h tends to 0, f a minus h minus f a divided by minus l, and it is denoted by l f dash a. Right-hand derivative is equal to limit h tends to 0, f a plus h minus f a divided by h, that is denoted by r f dash a. Left-hand derivative is defined by this limit, denoted as l f dash a. Right-hand derivative is defined as limit h tends to 0, f a plus h minus f a by h, and it is denoted as r f dash a. If these two limits exist finitely, meaning thereby its value is finite. If these two limits exist finitely and they be equal, that is, if left-hand derivative l f dash a is equal to r f dash a, so if l f dash a is equal to r f dash a, then we say that this fx is differentiable or derivable at x is equal to a. That is f dash a exists, and the value of f dash a is the common value for l f dash a and r f dash a. Whatever value comes here, if they be common, that is the two are equal, their derivative exists at x is equal to a, and whatever be the common value for a, that is the derivative of the function at x is equal to a. Now I shall explain it with the help of an example. So let us take an example. Let fx be a real function defined by x cube plus 2 at x is equal to 5. fx is a real function, and I have to look into the differentiability of this function at x is equal to 5. I shall find out firstly l f dash 5, that is the left-hand derivative, limit h tends to 0, f a minus, you just compare here, and the value of a will be 5 here, f a minus h minus f a divided by minus h. We obtain this. Left-hand derivative, this is limit h tends to 0, fx is x cube plus 2. So for this, it is 5 minus h. In place of x, we are having here 5 minus x. So x cube plus 2 minus fa 5 So it is 5 to the power 3 plus 2 divided by minus h. This plus 2 and minus 2 reduces to 0, and thereafter we simplify it. Limit h tends to 0. We put it either in the form of aq minus bq, or we expand it as a minus b whole cube, that is aq minus 3 into a square b plus 3 a into b square minus b cube. This is for this, and then minus 5 cube. 5 cube are divided by minus of it. You see that 5 cube and 5 cube, one with the positive sign, another with the negative sign, reduces to 0, and after that taking minus h common out of all from the numerator, we have h tends to 0 minus h. What remains here? H square becomes plus, this becomes plus, that is plus 75h. 75h is already common, and minus 15h divided by minus h. Cancelling it and putting h is equal to 0, we have it is equal to 75. Always using the formula, we must be cautious that the sign must be proper. I have taken minus sign common, so it becomes plus here, this becomes plus here, and this becomes minus here. So h is common out, so it is h square, it is only 75, and this is 15h. Cancelling it, putting h is equal to 0, it is 75. Similarly, we find out Rf dash 5. We find out this limit h tends to 0, f5 plus h minus f5 divided by h. So it is equal to limit h tends to 0. We have it is 5 plus h whole cube plus 2. This is for the first, and minus it will be 5 to the power 3 plus 2 divided by h. Again, the 2 cancels with the 2. This plus 2 and minus 2 reduces to 0. Again, we can use either aq minus bq formula, or we expand it. What we feel convenient, we do that. Both the formulas are known to us. That is, limit h tends to 0, aq plus 3a square into b plus 3a into b square plus bq, and finally minus 5 to the power 3 divided by h. Cancelling the 2 reduces to 0, and taking out h common from the numerator, because it being common in all. So we have 75 plus 15h and plus h square divided by h, cancelling it out and putting h equal to 0, it is 75. Thus, what have we obtained here? That is, the left hand limit is 75 and right hand limit is 75. The two are finite and equal. Therefore, the derivative of the function exists at x is equal to 5. So here we have LF dash 5 is equal to RF dash 5, and the value obtained is 75. Therefore, fx is differentiable at x is equal to 5, and the derivative obtained, that is f dash 5, is equal to 75. And further I shall give you the more examples in the next video. Thank you very much.